Previously, we computed the cohomology groups of the punctured G-hole torus. Now, we can use this to compute the cohomology group of the G-hole torus. To make things psychologically easier, we will change all of this to G-1 here, so that we can use induction hypothesis. Remember, our idea was to cover this G-hole torus by a punctured G-1 hole torus, right? And then a punctured torus. That intersection is gonna be homotopic to S1. Now, because every open set in this covering and the intersection are connected, we have a long exact sequence starting from H1. Then remember that in the video about the inclusion map of the circle into the punctured torus, we have proven that this is the zero map. Now, next, by our previous video, we know that this H1 of this punctured G-1 hole torus is just H1 of the G-1 hole torus. Right? And similarly here, H1 of the punctured torus is just going to be isomorphic to H1 of the torus. Finally, since S1 is of dimension 1, we know that this H2 is 0. Alright, so now let's put all of this together and use induction to find the cohomology of this G-hole torus. Our claim is that the one cohomology groups of this G-hole torus is going to be isomorphic to R to the 2G, and then the second cohomology group is going to be isomorphic to R. So let's check that. To make this easier to follow, let's do this concretely. So let's look at the case when G is equal to 2. Then this part of the sequence, right, shows us that we have an isomorphism between H1 of these two hole torus and the direct sum of H1 of the torus with itself. And from our discussion of the cohomology of the torus, we know that each of these is isomorphic to R2. So then this is just isomorphic to R4. Alright, so now let's look at the next part in the sequence. We claim that these terms here are 0. And why is that? Well, that comes from the discussion here, right? Because we know that H2 of the torus is R. So then from the discussion here, we see that H2 of the punctured torus must be 0. So this is just 0 map. So this map in particular from H1 of S1 to H2 of this two hole torus must be surjective. But it's also injective because the kernel of this map must be equal to the image of this 0 map by exactness here. So this is an isomorphism, and thus we get that the second cohomology group here of this H2 is going to be isomorphic to R. Well, now observe that again, then this will mean that H2 of sigma 2 minus a point is going to be 0, right, by this. So then we can use it again in the case when G is equal to 3 and so on. Thus, repeating this exactly the same argument for G equal to 3, we can show that this theorem holds for the 3 hole torus and so on. Thus, we see that for a general G-hole torus, the H1 cohomology group is isomorphic to R to the 2G, and H2 is isomorphic to R.